Brilliant. My dear friends, could we please welcome to the stage, a little bit unplanned, so sorry about this, but give a big hand to the main man, Mr. Glenn Jocher. Glenn, how are you doing, mate? Great to see you. Listen, I thought I might pull you up on stage just before we kick off. I mean, obviously, we're going to be leaning heavily on your expertise today.
Absolutely. Thank you so much for the invite, Oyson. Yeah, and that was
No
a
worries.
tremendous intro. I think as a presenter, you're unbeatable. This is the second year that you're helping us out with the event, and there's nobody that I'd like better here. This is YOLO Vision, and let me introduce myself. I'm Glenn. I'm the founder at Ultralytics. I've been doing this for a few years, and we are here in Madrid for the second year in a row at Google for startups. We go quite a ways back. We were here before coronavirus in person, building the seeds of what we have today, some of the greatest edge detection models and computer vision models out there. So I'd like to give a huge thanks to Oyson for that amazing intro, to the team that has helped us put this together, Google for allowing us to so kindly use their venue, and for everyone that has come here from all sides of the world to see what we have in store today. So we'll try not to disappoint. We've got a few surprises in store, some great talks from thought leaders and experts in the AI space, and I think we're going to have just a great event overall. And last but not least, we have an amazing after party. It's at the Four Seasons Hotel in the center of Madrid at possibly the best cocktail bar in the city, which is Isa. So that starts at, I think, 9:30, and we'll see you there after this.
What can I say? Glenn, you had me at cocktails. Big round of applause for Glenn Jocher. Fantastic. Thank you. Thank you for spontaneously coming onto the stage. That's brilliant, man. I thought I'd put you on the spot. Just get the adrenaline flowing first thing, right?
I like it. Impromptu.
Hardcore. All right, my friends. We're actually, that's perfect timing because we're going to just segue in to a panel that we're going to be hosting now on the stage. And this is all about YOLO in the age of generative AI. Now, of course, there's a big story around YOLO Vision in terms of, you know, moving towards AGI. I know that you're a huge kind of advocate of this. This is like a real passion for you.
Absolutely,
and,
yeah.
Yeah, that's brilliant. So we're going to actually get into some of the nuts and bolts now. And we are delighted to be joined by our dear friend who has traveled all the way from Xi'an he's born in Xi'an in the Sichuan province in China, and he's currently living in Chengdu, which is a place I had the pleasure of going a few years ago. And we had a great old chat earlier about the joys of extremely spicy food in Chengdu, particularly the hot pot. I said that was great fun. My dear friends, would you please join me in welcoming to the stage? He's the co-author of YOLO V8 and a senior machine learning engineer at Ultralytics. Give it up for Jing Qiu. Welcome to the stage, Jing. Thank you. Yes. Awesome. All right. I have a mic with your name on it, Jing. Oh, there you go. There you go. Look at this. Mic. So have a seat, guys. Fantastic. And of course, it is always a delight to welcome the founder and CEO of Ultralytics in person, Glenn Jocher. He's here, the main man. Brilliant. And we are also going to welcome, by the magic of technology, Ao Wang, who joined us from Tsinghua University. So have we got Ao in the house? Oh, have we got Ao in the house? Right. So this is completely live, just in case. This is not an AI version of Ao. He is joining us in real time. Ao is currently working towards his PhD degree in the School of Software with Tsinghua University, and he is the co-author of YOLO V10. And yes, he's joining us by the magic of technology, I believe it's called. Well, I tell you what, while we're giving Ao a little bit of time to join us using the magic of video, it'd be lovely just to get a quick overview from your good selves. Just a little bit about, you know, your background, how you got to where you are. Now, Glenn, I don't want to put you on the spot again, but I love the fact in your bio, it's like it says you founded Ultralytics to lead the United States National Geospatial Intelligence Agency. That is so awesome. Talk to us a bit about what that is and how it's led you to where you are today.
No, absolutely. So we've done quite a journey to get to where we are today. So I founded Ultralytics initially not for AI, but for particle physics. A few agencies around Washington, D.C., intelligence agencies, were interested in a new type of particle called an anti-neutrino. It's very strange. It oscillates into different flavors. We don't understand it very well, and there's a lot of science to untangle there. And so I created the company to engage in this R&D. And I worked on this for about 5 years. And this is how I started getting into more of the data science, data analysis, and ultimately into the machine learning that transformed into YOLO and what we have today. So the applications there were really similar to computer vision. You're detecting particles, you're classifying them, and a lot of the same architectures and techniques in anti-neutrino detection work just as well for person detection, which is kind of strange, but that provided really a great springboard to come into the computer vision space, which is, I'd say, equally challenging, but possibly a bit more rewarding in that you can impact more lives directly.
Well, hashtag mind blown. I mean, that's pretty incredible. It's not, I do a lot of conferences, and I can assure you, it's not every day you get to hear about neutrinos on the stage. This is pretty advanced stuff. Coming over to your good self, Jing. Now, I know you're very passionate about AI, and this is really driving you and is driving you to where you are today. So talk to us a bit about, what kind of, makes you jump out of bed in the morning and, kind of throw yourself at YOLO.
Yeah, because I'm very passionate about AI since I'm in college, and 2 years ago, I'm keeping learning and exploring the AI, and 2 years ago I met Glenn and in GitHub, and we were developing the YOLO V5 together, and we finished the YOLO V5 and the final version, right? Yeah, and then we created the YOLO V8 together. Yeah, which is incredible journey. Yeah.
Yeah, GitHub is it's an incredible way to share. People that you've never met before come and help you. You can contribute to their work. So it's a great community, and it's really a great way to get started in AI.
Yeah, great ideas and great minds come together in this great community for sure. I'm just going to do a little gesture to our wonderful AV team at the back. Do we have sign of Ao joining us or not? Más o menos, question mark. Okay, we're just going to crack on, and if Ao can join us, we will direct some questions at him. And Ao, if you are watching us on the live stream, we're really sorry. We are trying. We got a team at the back of this room trying to connect with you.
There's quite a team back there working.
Oh yeah, phenomenal team. Yeah, the best of the best here. So we're doing our very best. Right. So I thought I might just start with a bit of a techie question directed at your good self, Jing. Now, could you talk to us a bit about the key differences between generative AI models? So, we have large language models, we have VLMs, visual language models, and also diffusion models for image generation, and also we have computer vision models like YOLO. So you could kind of, imagine I know very little about this. I mean, you don't have to imagine very hard, but, you're explaining it to me and pointing out the differences.
Yeah, I mean, I think the most difference between the generative AI models and the computer vision models, it's the generative AI models are designed to generate data and generate contents and images and pictures. And for the traditional computer vision models, it's designed for analyzing the existing images. So it's one for generating and one for analyzing existing data. And another difference, I think, is the deployment. Actually, I mean the size of model are very much different. And the generative AI models are quite large. Visual, people, if you want to deploy the models, they need to deploy in super powerful servers and maybe cloud services. And for computer vision models, especially YOLO, we could deploy the models in some edge devices and a mobile phone. And yeah, I guess that's all.
Nice, Glenn. What say you?
Oh yeah, so
we got Ao, brilliant.
I think we just got him. All right.
Can we get a round of applause for Ao, please? Fantastic. Welcome, Ao Wang. Great to see you. Good morning.
Welcome.
Hey. Oh, so Ao,
I just have
started. We've explained that there's some technical stuff happening. So you're very, very welcome to join us. We have literally just started talking about the differences between, different Gen AI models, between Gen AI, LLMs, VLMs, diffusion, etc. Jing has just kind of explained to the novice, me, how this all fits together. And Glenn, you were kind of jumping in there with some more detail.
Yeah, no, absolutely. I think for me, the difference is really about the size of the models and the price tag, the size of the price tag associated with training them. Probably also collecting the data set to train them. So we're talking orders of magnitude, probably three. 3 orders of magnitude is 1,000 times larger. So for the YOLO models that we work on, they're small, they're fast. We can train them in a few hours or a few days. And the smallest YOLO model that we have is about 1,000 times smaller than the smallest LLM. So 3 million to 3 billion parameters. So the difference is enormous, I think, when you look at it technically. And of course, the edge in the cloud deployments. The large models just aren't suitable for edge. And what we see in the computer vision space is typically people want to run their own models. They want to run their inference, train the model, and so on. So it's really different, and they both have their applications. I don't think they directly compete to the level that I was seeing originally. So I think in this space, there's room for everybody. And I think LLMs, I think, have also contributed greatly here at Ultralytics on the R&D side, helping us code up those Python functions and train these models. So.
Excellent. And that's, you know, a very different overhead in terms of servers, in terms of energy use, in terms of environmental impact as well. I mean, this is all like tick, tick, tick. This is music to my ears. But Ao, I wonder, would you like to jump in and just kind of introduce yourself to the good people here in the Google for Startups campus in Madrid, and also the many people joining us via the live stream. Just talk to us a bit about the kind of work that you're doing and your kind of personal relationship with this field of AI.
Yeah, of course. First, I'm very sorry to be late because some network issue, and then I'm Wang Ao, and I'm from China. I'm graduating from the Tsinghua University, and in my school, I actually first major in the software engineering. That sounds like not very related with computer vision or the Gen AI. Then, after graduating from school, I started to learn the computer vision and the deep learning. And actually, I first learned the famous YOLO model, and I tried the Ultralytics framework, and it is very amazing because at that time I have actually very little experience with object detection or the computer vision, but I can just use the Ultralytics framework to implement some very amazing features like detecting various objects and so on. So I get more interested into this area, and I started to learn more about the computer vision and the YOLOs, and then we are also working on the YOLO models and try to make it more fast and more accurate. Thank you.
Boom, watch this space. I love it. All the way joining us from China. Fantastic.
Thank you.
Yeah, and I love that description, the famous YOLO model. Absolutely, yeah, and here we are. This is just brilliant, uniting the world. So Glenn, you actually mentioned that there are, you know, a lot of improvements in terms of overheads, in terms of the server overheads, how quick and agile this kind of YOLO code is. But, you know, talk to us a bit about the influences or improvements to to computer vision models like YOLO that are maybe adapted from or linked to or influenced by Gen AI models. How does that kind of upstream work from Gen AI to computer vision?
Yeah, that's a tough question. So let's see. So Gen AI is it's a real novelty for us. So this really exploded last year with ChatGPT. Before that, the term LLM, I don't think you'd ever heard of that. And before that, it was called NLP, which is natural language processing. So I think there's a lot of effort around NLP, a lot of effort around computer vision. But I think what you've seen really is not just attributable on the software side. So it's not just algorithms that have evolved and improved, but it's also the hardware. So if we take a step back and we go to the true origins of machine learning, it's really around the 1970s in the United States that scientists kind of created this theory for mathematical interaction that really mimicked the human brain. Unfortunately, they wrote this down on a napkin and they had no computers to really test it on. So this kind of stayed in the theory section. So in science, there's theory and then experimental scientists, and these guys were really theoreticians. So unfortunately, they just did not have the hardware to realize the idea. But this is pretty common in science, actually. And then maybe decades later, the hardware finally catches up, or someone creates an experiment to validate an idea. So what happened is Jensen Huang here. He started NVIDIA. He had this idea to parallelize CPUs. CPUs typically run in series. They operate really quickly, but they do one thing after another. And Jensen's idea was to create a processor that did things slower, but many things in parallel. And this is actually similar to the human brain. The human brain operates very slowly, actually. Signals travel on the order of like meters per second. So it's incredibly slow, but there's so many signals traveling at the same time. And this GPU technology started in gaming and then evolved into AI and into things like cryptocurrency, and it's really taken off. And so I think not just that, but also I think node processes have shrunk. The energy used to train the models has shrunk, and we see that everywhere. So not just in the cloud for training, but on the edge for deployment. And this has allowed much larger models to appear. So whereas, say, 10 years ago, a 3 billion or a 70 billion parameter model was unheard of, it was impossible, except perhaps on a government supercomputer. Now, startups can recruit investors, buy a bunch of GPUs, and get to town training these LLMs. And also the data required to train them is now much more prevalent. So now the text data, it doesn't require as much labeling because the text data is its own sort of label. Like the next tokens in a sequence are all you need to train a model. And so I think these three things coming together have really propelled the LLM field. The same is true for computer vision, but perhaps to a lesser extent. We've benefited from the hardware, but on the training data, we still need to manually label data. And this is something that is getting some interesting updates too with models like SAM and SAM2. But for the most part, for specialized data that's not very common, we still need human annotators, and that's a bit of a bottleneck in computer vision.
Fascinating. My goodness, that really is fascinating. It's a proper history lesson there from the origin of this whole thing. And I believe we have a speaker from NVIDIA joining us.
That's right. Yes, we do. Yes.
Awesome. Awesome. Yeah. Although only the best people here.
Not Jensen, unfortunately, but
not yet. Not yet.
Maybe next year.
Excellent. Excellent. That was completely fascinating. So I'd just like to kind of throw that open to Ao and Jing. Is there anything you want to add to that? You don't have to add anything, but that was pretty cool. Yeah.
Well, I think like for generative AI models, mostly the architectures are like transformers and attention mechanisms, right? And actually for like traditional computer vision, we also have like transformer-based architecture. Yeah, and it improves the accuracy a lot. Yeah, but slightly slow down the speed. Yeah, and I remember the first object detection model that used the transformer is, I remember, is the DTR, and I think this is the first like end-to-end model, end-to-end object detection model, and their idea is to like treat the object detection as a set of prediction, and yes, and then they just output a set of bounding boxes and categories. Yeah, and they support like end-to-end training. And the first time they don't need the NMS as post-processing. Yeah, and after that, yeah, I guess this is the first time like using the transformer-based architecture in object detection. And after that, like 2 years ago, the original DTR models are like extremely slow actually. And like 2 years ago, there's another model based on the DTR called RT-DTR, which was made by Baidu team. Yeah, and they were using like a hybrid architecture that uses CNN and also transformer. So for the backbone, they use the CNN to like gain a faster speed, and in the neck part, they just use some transformer-based layers to capture the global context information and to gain like better results, better accuracy, and maintain the faster speed. So yeah.
Fascinating. My goodness. Like real kind of hands-on examples. Really, this is the kind of state of the art is happening in the field right now. I wonder if we could come over to your good self, Ao. I mean, have you come across any examples of this overlap between, Gen AI, computer vision, etc.? Anything that you're seeing from your side? And I just grand piano in the background, so I'm getting serious Zoom background envy. That is brilliant. But yeah, Ao, what's your take from over there about this overlap between Gen AI and computer vision?
Yeah, I first feel like that recent years have witnessed the significant advancement from both the Gen AI and the computer vision, like the larger and larger language models, and also the different versions of YOLO models. And I think the both of two can actually benefit each other and become better. For example, I first learned that the masked image modeling pre-training in the computer vision, and is also inspired from the pre-training of the Gen AI, and it brings the notable benefits for the models in the field of computer vision. And also the lightweight architecture models in the field of computer vision also inspire the models in the Gen AI to become more lightweight and more suitable for the edge devices. For example, there are more and more small large language models, and they become more light. I think these are also inspired from the lightweight models in the computer vision field. For example, the YOLO series models. So the two of these can actually benefit from each other and become more advanced in the future.
Phenomenal. Thank you so much. Excellent. Thank you. I'm going to throw this question out to all three of you. Are there any specific Gen AI models or tools that you've come across that you use, that you like, that you think are useful? You want to just give a shout out? Yeah, do you want to jump in? Okay, cool.
Sure. I'll go ahead and take this one. Yeah. So I think the whole coding experience for developers in general is just transformed. I remember when I first started working on ML, I'd never done Python before, and it wasn't too bad because I'd been using something else called MATLAB before. But I tried to make an iOS app, and that was a painful 6 months for me just to get this thing out the door. And now you can just kind of ask a question, code will be generated, and so I really find myself moving away from the low-level coding to sort of, I guess, like orchestrating architectures more and just getting the code from Cloud. So Cloud 3.5, I'd say, is my go-to for coding. I'd say for other tasks, I prefer GPT's 4.0. I think that's pretty good. I don't really operate on a lot of open source LLMs. I'd say the startups have made it just too convenient to use their cloud APIs. So I think for me, it's actually helped the computer vision field because it's accelerated the pace that we can innovate. It's sort of taken the mathematician from writing equations to using a calculator. So,
Phenomenal. So you kind of mentioned that you're kind of moving away from the low-level coding side of things. Do you find this frees you up creatively to look at bigger picture stuff?
Yes, definitely. And also, ironically, I think I've learned coding best practices from cloud. After I saw the examples it started creating, I looked at my code and I thought, wow, nobody can understand this. It's I used to write very succinctly, to put it lightly. No comments, like really short variables. And my main motivation was to make the code as short as possible. And it turns out that works when you're just working by yourself. But as you start to build a team, that's not the best strategy. So now that I've seen what the LLMs produce, now I kind of mimic that actually. So I've started learning from the LLMs. So.
I love that. That's absolutely brilliant. You're LLM code teacher. That's so nice. Yeah, and I suppose like the LLM is going to bring you, the 360 vision, some of that context, because it's coming from all this different data sources. Yeah.
I guess the students become the teacher at this point.
Oh,
not sure what's next.
Nice. We're going to wait and see what the LLM has in store for us next. Brilliant, brilliant. I love that. Now, we have been talking about the history of this technology, the NVIDIA example, how this has come over to the field of computer vision. But talk to us a bit about this intersection between YOLO and generative AI in terms of it shaping the future of computer vision and artificial intelligence. How's that overlap going to pan out? What do you see possibly in the future? This might be a question for your good self, Glenn.
Oh, no. I was hoping to pass this one over. This is a really tough one.
All right.
Okay, so I have to say, when we saw LLMs come out as in the AI space, this is a nerve-wracking space to live in, because you never know what's going to happen. You never know when you're going to wake up and suddenly there's going to be a new technology that you've never heard of that's just going to put you out of business instantly or make you irrelevant. And so at first, I was looking at these models and I thought, okay, this might be something that's more robust than what we have in the computer vision space, where we have to train something specific. And I've kind of refined my understanding really to, I think, accommodate a wider variety of points in the application space. And so just like there's different sized vehicles, like you can get a little bicycle, ride around by yourself, or if you need to move around 50 people, you get a big bus. And so there's not really kind of like the perfect vehicle for one size fits all scenarios. And so what we see is that in enterprise applications where organizations need to process lots of images, like a manufacturing site that's making millions of widgets a day, and they want to do, say, quality assurance on them. So this is something that they're always going to prioritize: energy efficiency, cost, speed, latency. And this is something that they need something really specific for. So they don't need a model that can do many different things. They just need a model that can do one thing very well and hopefully very cheaply and quickly. And so I think there's always going to be a space for both types of applications. Robust models that can, for example, describe a scene, but take longer to do that and perhaps cost a bit more money. And models that are much smaller and can do less things, but they do that quite well. And so I use the analogy of if you need to go see a doctor, then you probably want to see just a doctor, not a doctor that's maybe also a lawyer and a computer scientist and so on, because those aren't really your concerns at that moment. So,
absolutely. So tailor-made bespoke solutions for exactly that scenario, which is, kind of elastic and expandable and iterative. Brilliant. I like that very much. Yeah.
But also, I think it's to top it off. I'd like to bring them closer together. I think there's architectural applications. I think in the computer vision models where we divide the scene into a fine grid, that I think may be applicable to the LLM space. So I think you may be able to start combining localization with description, which is something that we're, I think, seeing LLMs struggle with right now. So.
All right, the student becomes a teacher, becomes a student, becomes a teacher.
So virtuous cycle, yeah.
That's fantastic. Brilliant. Now, I just spotted Hannah over there with a cube, the cube of power, and she is ready to throw this at your face, my friends. If you have a question and you're feeling brave and you're feeling like you're going to catch that, just put your hand up. Yes, we've got a hand. Do we have a hand? Yes, we do indeed. Yeah, gentleman over there in the stylish green polo shirt. Oh, good catch, sir. Could you introduce yourself to our room and our gazillions of folks joining us on the live stream?
Okay, my name is Alberto Garcia. I'm working for an aerospace company, and we are dealing with computer vision issues. So my question is to Jing, that he already mentioned about vision transformers. And I would like to know if this is the future for the object detection models, and if so, what will be the challenges in terms of data set size, training, etc. etc. Thank you.
Yeah, so like I just take the example, like there's like a model RTDTR, which is a hybrid architecture, and like it's the first time like make the real time and end-to-end model, and also like there's another hybrid architecture which is actually YOLO V10, with like a bunch of CNNs, and I remember there's one layer which like the all embed um, attention mechanism, and that's actually improves the performance a lot. And the position he embeds the attention mechanism is the last layer of the backbone, which is like a very small feature map. And to that, like we could like the minimal additional computation, and meanwhile improve the accuracy. I guess maybe, I mean, I may be wrong, but I guess the hybrid architecture could be the future, maybe the future architecture for the computer vision, or especially object detection. Yeah, and meanwhile keep the speed and improve the accuracy. Yeah.
Fantastic. Did that answer your question? Excellent. Happy face, nodding. Excellent. That's what we like. Do we have another question? The cube of power is oh, there it is. Yes. Do we have another question? Just put your hand up, or Ao, do you want to jump in with any comments there? You don't have to, and I appreciate there's a little time delay, but just throw something at me if you want to just jump in at any stage. Any more questions? Do we have another question? Just put your hand up. Do we have? Yes, I'm seeing a hand being lifted from that. Yes, thank you. Good man. Thank you so much. We have eyes in the sky up there. Just a reminder, make all your friends jealous, spread some FOMO, use the hashtag YV24. And we have another question. If you wouldn't mind introducing yourself to the room, thank you.
Hey everybody, I'm Burhan, community ML community lead. I'm on YouTube and Discord, checking out all the questions coming in from the community. One of the questions came in was asking about if there were any plans for using meta training for improving model performance.
Meta training. I mean, as the non-technical person on the panel, could you expand on meta training? Is it like not the platform, or the concept?
Yeah, there were a whole lot of details. I'm not quite sure.
Was it Mark Zuckerberg asking the question?
Maybe.
Zuckerberg. I'm totally anonymous. Did he have no legs and live only in the metaverse?
Was he wearing a pair of weird glasses?
No, probably.
All right. Meta, all caps.
Yeah, I'm not sure. I think we probably need a bit more explanation, because that's not ringing a bell for me.
Yeah. Nice try, Zuckerberg.
Yeah,
if that's your real name.
We tried.
If you wanted to throw a wrench in it, yeah, I think it worked.
Do we have any other questions from the community? Oh, we have a question. IRL, fantastic. Thank you. Okay. Yeah, we're putting Hannah through her paces there. She's racing down the stairs. This is Olympic level mic throwing coming up just down here. Great. Second row, right in the middle. Woo! Good catch. Look at that. Excellent.
Hi, I'm Maria, and I'm actually like the intruder here because I work in language technology. I'm an NLP engineer at Verenia. And this is why my question is about multimodal models. And we were talking about region here. But I actually would like to ask whether you see any actual enterprise application of some visual language model, or maybe vision audio models, or like some sort of mix and match of all the modalities you can possibly imagine?
Yeah, that's a great question. I think there's clear applications in the LLM space, and there's clear applications for computer vision. The most common computer vision applications would be in manufacturing, quality assurance, things like retail analytics, fraud detection for documents, and so on. I think for hybrid models, models like Lava, for example, I think like image to text models, that is something that we haven't played around with as much. I could see some applications, but it also, I always say that you should use the simplest tool to solve the problem that you have. So in computer vision, that would be if you can get away with a classification model, do that instead of a detection model. I think in the hybrid approach, that would be something you'd have to look at too. So I think you'd need to find an application that could only be solvable by a hybrid model rather than a more specialized model. So I'm not sure. I can't think of any off the top of my head, but that doesn't mean they don't exist.
Tremendous. What an interesting question. This is great. I'm learning so much. I mean, I am starting from a lower bar, to be honest, but that's fascinating. Yes.
Yeah, no, I think like one of the very first examples of computer vision applied at scale, I think was Twitter. So in any type of social media, there's a lot of inappropriate content that gets uploaded. Before that, there were human reviewers. And now a lot of that is done by simple classification models. So I think an image to text model could accomplish the same. But you'd have to look at the flops and the energy, and you probably see that it's taking more. And so I think that's where the question mark raises in my head. There's got to be something that that a descriptor could do that a classifier wouldn't be able to do.
Wow. As with excellent. Okay, fantastic. We're getting a thumbs up from the audience here. Okay, my dear friends, I'm afraid that is all we have time for. We've got to change over the stage. We're going to go on to our next session. So please join me in showing your full appreciation for our wonderful guest all the way from China, Jing Qiu. Thank you, Jing. Our wonderful guest, Ao Wang, joining us from Tsinghua. And of course, from Mr. Jocher, founder and CEO of Ultralytics. Absolutely awesome.
Thank you.
All right.